All right, this is the Algebra 2, Unit 6, Lesson 4 video over synthetic division. Synthetic division is a method of dividing polynomials that is much easier and more efficient or just simpler to write than the method we learned previously. What I mean is, if you remember from a few lessons ago, lesson 2, we had this whole process of dividing polynomials. And you can see we had to do all these different operations, multiply things, subtract to get this answer here. So I'm going to show you how to do this using synthetic division. And I think you'll agree it's much easier to work with. So let me make up another problem here. Let's say we have x plus 3 divided by x squared plus 7x plus 12. So obviously we talked about how long division works, and you do this whole thing, you just subtract, multiply, do the whole thing. So instead of doing that method, I'm going to show you how we can use synthetic division. So synthetic division is written a completely different way. So I'm going to rewrite this expression using synthetic division. So first of all, you make this little t, sideways t. And in here, you're going to write the coefficients of the dividend, and you're going to write the 0 of the divisor. So what I mean by that, I'm actually going to move this down a little bit. Let's do this again. So when I say the coefficients of the dividend, I mean the numbers 1, 7, and 12. And when I say the 0 of this, I mean whatever makes x plus 3 equals 0. In this case, negative 3. So negative 3 will go in for x to make this negative. So we're going to write a negative 3 here. So that is what we're doing when we set up synthetic division. We're writing the coefficients across this section. We're writing the 0 of the divisor over here. And then there's going to be a basic sort of flow to this problem. And I'll kind of write out the steps as we go. First thing you do every time, bring down the 1. Bring down the first term. Bring down the first term. So I'm going to write that down. Bring down lead term. So I'm going to bring down that 1. Step 2, multiply by divisor. Divisor being the negative 3. So in other words, this negative 3 gets multiplied by that 1. So I'm going to do negative 3. So we're going to do negative 3 times 1, and that's going to be negative 3 here. The next step is to add next column. That being this column right here. So I'm going to add that column. I'm going to do 7 plus negative 3. 7 plus negative 3. And I'm going to get 4. And then I'm going to repeat that process until I am done. So again, I'm just going to keep going back to 2 and repeating that process until there's nothing else left to do. So negative 3 times 4 is negative 12. Erase that. Negative 12 minus 12 is 0. So that means that there is no remainder. Then I'm going to after I'm done repeating that process multiple times, I'm going to rewrite new expression. Okay. The new expression in this case is going to be this rewritten as x's and coefficients and whatnot. So it's going to be one less than what I started with. So since I started with 2 or squared, this first term, this 1, is going to be just x or 1x plus, and then I go down 1 degree. So 4 is just going to be 4. Now, obviously, there's nothing in the final term because we got 0. But if there were, that would be the remainder of this answer. So the final answer is x plus 4. So I'm going to do a couple more examples here. We're going to do this example that they show us here. We have 2x to the third minus 5x squared minus 17x plus 20 divided by x minus 4. Let me rewrite that whole problem over here. 2x to the third minus 5x squared minus 17x. Sorry about that. Plus 20. And that's going to be divided by x minus 4. All right, so let's talk through again what we do to rewrite the expression in synthetic notation, or synthetic division. So we're going to start with the coefficients of this right here, and they're going to be going across the top of my little framework. 2, -5, -17, and 20. Then I'm going to write the 0 of this term. So the 0 of this x minus 4 is x minus 4 equals 0. X equals 4. That is the 0, so that goes here, the 4. And then I begin doing the process. I move down the 2. I multiply 4 times 2, and I rewrite that answer here. Then I add down. So 4 times 2 is 8. -5 plus 8 is 3. Then I do, change a different color, sorry about that, is 3. 4 times 3 is 12. -17 plus 12 is -5. Sorry, let me use a different color. Is 5. And then do it again. 4 times 5. Write the answer. 4 times 5 is. I'm going to back up for a second. I made a mistake. -17 plus 12 is -5. So then 4 times -5 is -20. And those make 0. So then we've gotten our final kind of situation here. And all we have to do is rewrite it back in a expression. So because my initial first term was to the third, my new answer is going to have 2x to the second. That's this, plus 3x minus 5. And then there is no remainder. We'll do an example in a second where there is a remainder. And so this is the whole expression. So if you go to the lesson, you're going to see the first part of this is just, obviously there's some vocab there, number 1, is to just choose the correct equation represented. So the thing you need to understand is, starting up here, this right along here is what you would have written at the very beginning. So we have -18, -14, through 5, and 3, and we're looking for one where it's constants, x squared, x to the third. We need to make sure that whatever is in the divisor position has a 0 of 2, and then we need to make sure the answer follows the pattern as well. Notice there is a remainder here, and this is a good example to show you, the way remainders are written in these types of problems is this is going to be rewritten as -2 over the original divisor. So just to be clear, I went ahead and gave you that answer. The answer to this question is going to be this third option because we have 3x to the third, 5x squared minus 14x minus 18 divided by x minus 2, which has a 0 of 2. And then the answer is 3x squared plus 11x plus 8 with a remainder of minus 2 over, and then we always put it over the original divisor. So this is always the denominator of the remainder. So this is what a remainder looks like. All right, let's scroll down and look at some more. More of the same. You need to choose the correct example that matches the framework they've given you here. Again, follow the pattern. The 14 is the constant term, and then it goes up from there. And then remember that the answer has to be one less than the original in terms of the x's. X squared, x, constant, remainder. Then they actually have you do it. 4, 5, 6, 7, and then they actually have you set it up yourself. So I'm going to do a couple more examples just to get us, make sure that we're kind of all on the same page. So let's look at another example. See if they have any more that I can do here. Okay. Perfect. This is a great example. Right here. X to the fourth plus 0x to the third minus 3x squared plus 5x minus 6. Now, in the original problem, there was no term for this. If you look up here, it wasn't there. So anytime there is a missing x, like if it goes from x to the fourth to x squared, you need to, when you write their actual problem, you actually need to go in and add that term. So let's rewrite this on our notes page. X to the fourth, oops, sorry about that. X to the fourth minus 3x squared plus 5x minus 6 divided by x plus 3. So let's go into it. So we know we're going to set up the problem by doing 1, 1. Now, because there's a missing x to the third, we're going to put a 0 in the spot for that. Then we're going to go down. Minus 3, 5, minus 6. This has a 0 of -3. Again, that's because x plus 3 equals 0 gives a result of x equals -3. That's how I know what goes all the way over there. Then I'm going to go through the process. I'm going to move a little more quickly this time. I'm going to bring down my 1. -3 times 1 is -3. 0 minus 3 is -3. -3 times -3 is 9. -3 plus 9 is 6. -3 times 6 is -18. 5 minus 18 is -13. -3 times -13 is 39. -6 plus 39 is 33. So you can see this is a good example of one where we have a remainder. And that's because you can see it just didn't go in there evenly. It just kept kind of getting further and further away. So let's look at how we can write our answer when that is what happens. So when that happens, we're going to move down one term, or 1 degree. So since we started with 4, our first term is going to be x to the third minus 3x squared plus 6x minus 13. So we got down to our constant term, and then our last step is to do plus 33 divided by my original divisor. That comes all the way down here, x plus 3. And so that would be the final answer for that problem. And that's what you're doing in all of these down here until you get to number 9. Then we get to some review questions. I'm going to come back to those after I pause this video.